Alright, in my other video I totally mispronounced this. It's electrophorus. But anyway, same thing. We're going to charge this metal object through induction. And it's a little bit different than just regular induction because we're actually going to do something called grounding. But hopefully we can go through it and you'll understand what's going on. And I'm going to try my best to be as consistent as possible. So here's our first one. And what I normally like to do is ask you guys to draw in the protons and electrons. Remember, we want to represent what the charge is for these items, but not going too crazy. So the two focuses that we have today is the aluminum plate and then the styrofoam plate. What's important in that this one is a conductor and this one's an insulator. And pretty much all it means is that the electrons are stuck here, while here the electrons are free to move. And that makes a big difference. And it will hopefully make more sense as I draw through this. So both of these are, we're going to say equal size in our classroom. It's not. But initially it's going to start off neutral. So for number one, starts off neutral, meaning both items are going to have the same amount of protons and electrons. So 1, 2, 3, 4, 5, I'm going to do 6, just because to exaggerate certain things. Okay, so they both have 6 protons. Let me make sure I can count. I can. And 6 electrons. So I'm going to do my best at drawing around. They're going to be random. Both for the aluminum plate and the styrofoam plate, it makes sense to have the electrons next to it. You know, it's balanced right now. There's no reason. I mean, technically, all the electrons could be on top for the metal. Just like electron cloud, the probability is almost 0. But is it possible? The answer is yes. It could just have a random act where all electrons are on top, but in most cases for a metal, it's going to distribute fairly well throughout the item. Styrofoam is going to be more attached. There's no possible way that's all on the bottom or on top. It's all going to be next to its nucleus. But here we have a neutral item. They're both 0 charge. Oops, I wrote it twice. Because they have the same electrons equals protons. Okay, so that's our first one. Our second one, let's see if I can scroll. Nope, I have to click on this. Our second one is what we're going to do is we're going to charge our bottom plate. And we're going to charge it by rubbing. So we're going to charge by rubbing. Whoa. What happened there? We're going to charge by rubbing the bottom plates. And the top plate stays the same. So this has 1, 2, 3, 4, 5, 6 protons. This also has 1, 2, 3, 4, 5, 6 protons. The top one is still going to be the same. Okay, the bottom one, we're going to gain some. So here we have the original electrons. And then I'm going to draw some protons and electrons for my cloth as well. And as they rub, we're going to have a transfer of electrons. For something like this, I don't care where it goes. You pick whether the electrons move from the plate into the fur or the fur into the plate or cloth. In this case, let's just make it move into the plate. So these electrons are going to go in to the plate. Now, like I said before, when you're rubbing, does this strip off all the electrons? The answer is no, but I just want to exaggerate things, kind of like the picture. So I'm going to gain 4 electrons on the bottom. So the styrofoam plate is going to gain, in this case, 4 electrons. So this one's still a charge of net of 0. Here it has a negative 4 minus charge. Now what happens on the third step? So when you place the aluminum plate onto now my charged item, what's going to happen, and these two are kind of very close to each other, so I'm going to do both at the same time, is this one, let's see, They both have still one. Oh, why does it keep doing that to me? They both have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They both have 6 protons, but the bottom plate just gained a bunch of electrons, 4 extra ones. So it has its 6, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4 extra electrons. So this is a negative plate. The top is still neutral, but as it comes down, you know, these electrons, what it's going to do, it's going to start being pushed away because opposite charge attract, but similar charges repel each other. So as it comes down, these electrons are going to be pushed all the way to the edge. So at the bottom, even though they both still have 6 protons, the negative plate is still the same. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this still has a negative charge of 4 minus, and this is still a net charge of 0. But what's going to happen is all the electrons, remember, and it was really hard to draw, but there's a little lip right here for the aluminum pan. So what technically happens is all these electrons, I should have done 3. Let me refix that. All the electrons technically get pushed to the top. Now, do some stay at the bottom? Yeah, let me just do this to make it more realistic. So 2 get pushed to the top, 2 are distributed down here, and it feels okay down here because remember there's 4 extra electrons, so it kind of pushed certain electrons to the edge. So now what's going to happen is you're going to have a partial negative and a partial positive. Overall, it's still 0, but you're going to have a partial positive. So this is the induction part. So you're inducing a charge onto my aluminum plate, even though its charge is still 0. It feels positive on the bottom because of this extra electrons on the styrofoam plate, and negative on top. But it's trying to distribute its electrons as evenly as possible between the protons. So hopefully that makes sense. This is induction. So it's kind of like the balloon going against the wall. It's going to push the electrons away because it's trying to balance out the charges that it's experiencing. Because the bottom one's so negative, it's going to push some of the electrons up on my plate. Now, what we're going to do is we're going to do something called a ground. And a ground is interesting because when we touch it with our finger, we're considered a pool of electrons. I am much more massive than my aluminum plate. I have a lot more electrons. So in this case, between us, if I gain that extra electron or 2, it's not going to make a difference. Even if it's 1,000,000 electrons, it's not going to make a difference for me because I'm so much bigger compared to the plate. So the plate could get rid of electrons or gain electrons because of it. So when my finger or my body is going to act like the ground. Okay, the best way to think of it is a pool of electrons. And the reason why it's called the ground is the best ground is actually the ground, the earth. So if you've noticed on your outlets, there's 3 prongs. 2 of them is a live wire or hot wire. The other one's the return wire. So that's where electricity comes out, goes back in. And then the bottom one is the ground. So usually what happens is if you need to decharge something, you dump that extra electrons into the ground. And the earth is really good at taking or giving electrons. And that's why we have poles going down there. When we talk about lightning, that's what happens there. So my finger, so this is going to be my finger, is going to act like the ground. So what's going to happen is this. So let me kind of draw my positives again. So we always stick with 6. It doesn't change. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Remember, my electrons are still 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. This stays the same. And remember, it's still a net 4 minus. This one is still a 0. But what happened was all the electrons kind of moved to the top to balance out this charge. Since it feels so negative, what it wants to do when I ground it is, okay, ground is pretty much an opportunity for it to get rid of electrons or gain. And since, even though it's net 0, it feels negative because of its partner, the thing on the bottom. The styrofoam plate is very negative, so when it's on top of it, it feels more negative than it should. So when I ground it, what's going to happen is electrons are going to move out of my plate into the ground. Okay, so once it moves off, it's going to feel neutral. Does that make sense? So I probably should have done one more picture. But yeah, it's going to feel neutral after this. So finally, in the end, what's going to happen, and I probably should have done one extra picture, but oh well. Oh, I can't scroll down. Oh, there we go. So here, they still have one. Oops. See, they still have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The styrofoam plate stays the same the entire time. It doesn't gain or lose electrons after the rubbing incidents. 1, 2, 3, 4. So still a net of 4 minus. This one, what happened is that it lost 4 electrons that we drew on top. So now it has a net 4 plus. Now, does it have to equal the same on the bottom? No, I just made it that way. But now this one is permanently charged on top. This one's still negative 4. So this one never changed. So now if I ground it again, you should hear a little tick. You could put it back on the styrofoam plate, and you could do this over and over again. Now, over time, the styrofoam plate is going to lose its charge to the environment, and some of it might transfer into the aluminum plate because it is physically touching. But overall, it can last a fairly good amount of time. So that's kind of how you charge a metal. You induce a charge, you ground it, and then it's done. Now, could this be done without the little insulating cup on top? And the answer is no, because if you physically put your finger on the aluminum and you put it down, it's already grounding. So you're grounding the entire time, so you never could have this induced charge, right? If I touch it, it feels negative, so all the electrons are going to go into my body, but the moment I lift it up, it's going to get back into the metal. So by continuously grounding it, you're never going to have this isolated charge. It's just going to always be happy because of your pool of electrons. So hopefully that makes sense. Let me know if you have any questions.